Hey Math 3, I wanted to make you a quick video going over some notes that will help you after task 1.2 and heading into task 1.3. I wanted to just review some functions for you guys and their inverses. So I did get a lot of questions just in general. What is a function? A function is a rule, a process, an operation. So for example, if I put in the number 2 and I get out the number 4, some rule, some process, some operation made that happen. If I put in the number 5 and get out the number 10, some rule, some process, some operation made that happen. Well, what is that operation? Let me do one more and see if you guys can guess what that operation is. If I put in 21, I get out 42. Can you guys guess the operation? Hopefully you guessed times 2. Times 2 is the operation. So if we wanted to write this as a function in function notation, this is what it would look like. It would look like f of x is 2 times x, meaning 2 times 2 gives me 4. And 2 times 5 gives me 10. And lastly, 2 times 21 gives me 42. So that's what our function is. Our function is just a rule, an operation, something that gets us from an input to an output. So let's talk about function notation. You guys have seen this already. You saw this in task 1.2. This right here, this letter on the side, this is the name of our function. Name of the function is f. So we give our functions a bunch of different names so we can actually refer to them. Instead of calling it times 2, we can just say f. So in contrast, the name of this function is g. And this is so we can have multiple functions, and we can say, well, this function multiplies by 2, because that's what this function does. If we say, what does it do? It multiplies by 2. It takes the x and it multiplies by 2. But what does this function do right here? Well, this function has a few different steps. Now, let's not forget PEMDAS. Let's not forget our order of operations when we talk about this. First, it is going to square. So this function squares the input. I'm going to call it the number. Squares the number, or squares the input. Then it multiplies by 3. And lastly, it subtracts 5. So instead of having to say that every single time, let's take a number, let's square it, let's multiply by 3, let's subtract by 5. Instead of having to say that series of operations or that series of rules, we just say g. Well, if I want the number 2, let's apply the function g to it. The number 2, let's apply the function f to it. By saying let's apply the function f to the number 2, I'm saying let's multiply it by 2 and get 4. When I say let's apply the function g to number 2, I'm saying let's square the 2. So first step would be to square it, making, let's erase that, making 4. Then we're going to multiply by 3, making 12. And then we're going to subtract 5, leaving us at 7. So again, this right here would be f of 2, meaning we're going to plug 2 into f, and this right here would be g of 2. So the biggest mistake I see over and over and over and over and over is that, and I'm going to do this in different colors so you can see this is a big no-no. You say, hey, let's do f of 2. That is 2 times 2. So f of 2 equals 4, and now let's divide by this 2. So f just equals 2. No. This is a big no. I want to tell you, don't do this. Don't do this. F of 2 right here, this is the notation. That is not multiplication. It is not multiplication. Not multiplication. Nope, it is the notation. It's the notation. We're going to leave it just like that. You don't have to then divide by the 2. Same thing on this side. I found out that g of 2, actually let's keep this in red so you know don't do it. I found out that g of 2 equals 7. A lot of you guys want to divide by 2, so you just say g equals 3.5. No, don't do that. It's not multiplication. Not multiplication. It is just the notation. We leave it intact. We leave it intact. Don't do that. So, what is a function? A function is just a set of operations or a set of rules that lead you from an input to an output. I think of this as a function machine from our inputs to our outputs. And the function is what operation gets us there. Function notation is just how we indicate, well, we plugged 2 into f. We plugged 2 into g.